Hi, this is Mrs. Pettit, and today we're going to talk about arcs of circles. We're going to learn about identifying different types of arcs, determine the measure of arcs, recognize congruent arcs, and how to apply our relationships between congruent arcs, chords, and central angles. Before we can do all of that, we have a lot of definitions to get through. So the first is we need to understand what an arc is. And his arc is 2 points on a circle, and all the points in the circle needed to connect the 2 points by a single path. If we start with 1A, it says to give another name for arc RS. Arc RS means we would start at point R, go through all of the points on the circle until we get to point S. Just like a segment, it doesn't matter which end we start at. So we could also call that arc SR. We use the 2 endpoints with a little umbrella over them to signify an arc. 1B asks, what is the center of arc RS? And the center of arc RS would be point P, because the center of an arc is the center of the circle in which it's contained. C asks us to name all the other arcs in the diagram, but I'm going to come back to that in just a minute after we define what all of these other pieces of a circle can be. We want to be able to talk about what a central angle is, and a central angle is an angle whose vertex is at the center of the circle. So if I wanted to name one central angle, I could say angle RPS, indicating this angle here. When we talk about arcs, we can talk about 3 kinds of arcs. One is a minor arc, one is a major arc, and one is a semicircle. A minor arc is an arc whose points are on or between the sides of a central angle. So in this case, arc RS is a minor arc. We use 2 points to indicate minor arcs. If I wanted to name the other minor arcs on the diagram, I would have arc QR, which would start at Q and go to point R. So I would have arc QR is another minor arc. Think of minor arcs as being arcs that are less than half of the circle. A major arc is an arc whose points are on or outside of a central angle. In this particular case, arc RSQ would be a major arc. For major arcs, we use 3 points. 1 to indicate where it starts, 1 to indicate what it goes through, and 1 to indicate where it ends. So on our diagram, a major arc would start at R, go through S, and come all the way around to point Q. Think of major arcs as being arcs that are more than half the circle. So if we want to finish labeling up here, our major arcs would be RSQ and RQS. The third type of arc we're going to talk about is a semicircle. And a semicircle is an arc whose endpoints are the endpoints of a diameter. We typically use 3 letters to name a semicircle. So in the above diagram, arc QRS would be a semicircle. We typically use 3 points, so we clearly indicate which half of the circle we're talking about. So we typically use 3 points. So in the diagram above, if we're talking about arc QRS means we're starting at Q, going through R, and stopping at S, which clearly indicates we're talking about the upper semicircle. Because there are no other points on the diagram, if we want to talk about the lower semicircle in this diagram, we would have to call it arc QS with just 2 letters, because we would want to distinguish it from the upper semicircle. So arc QS would be the lower semicircle. So if we want to go up and finish our list up here of all the other arcs in the diagram, we would also have semicircle arc QRS and semicircle arc QS. Now that we know how to distinguish between the different types of arcs, let's talk about how to find the measures of those arcs. If we want to find the measure of a minor arc, the measure of a minor arc is the same as the measure of the central angle. So if we want to find the measure of arc AB, the central angle that contains arc AB is angle AOB. And the measure of angle AOB is 65 degrees. So the measure of arc AB is also 65 degrees. In circle Q, what is the measure of angle CQD? Well, angle CQD contains the arc CD, and the measure of arc CD is 125 degrees. So the measure of angle CQD is also 125 degrees. In circle R, what is the measure of arc EF? Well, in this case, again, the endpoints of the arc are the endpoints of a diameter. There isn't a third point on the upper part of the circle. So arc EF is referring to semicircle EF. And semicircles have a measure of 180 degrees. To find the measure of a major arc, we can find the minor arc with the same endpoints and subtract the measure of the minor arc from 360 degrees. So in circle O, if we want to know the measure of arc AGB, the major arc, then we would take 360 degrees, subtract the minor arc with the same endpoints, which is arc AB, which is 65 degrees, and we would get a major arc measure of 295 degrees. In circle Q, if we want to find the measure of arc CHD, the major arc, we would find the minor arc with the same endpoints, which would be arc CD, which is 125 degrees. When we subtract that from 360, we find a major arc measure of 235 degrees. If we want to talk about congruent arcs, we're talking about 2 arcs with the same measure and are parts of the same circle or congruent circles. So if we look at circle S, circle T, and circle U, and ask the question, are all 3 central angles congruent? Well, in that case, the answer would be yes, because as indicated by the box in the corner, all of them are 90 degrees. The question, though, are all 3 minor arcs congruent? That's a different question. So to answer the question why or why not, we could say no, they aren't all congruent. Arc JK is congruent to arc NV because they have the same radii. However, arc LM is not congruent to either arc JK or arc NV because the radius of circle T is not the same as the other 2 circles. So here we'll say because the radii are not the same. If we want to talk about which angles in a circle are congruent, we're talking about the angles that are less than or equal to 180 degrees. We can very clearly see that angle XWY is congruent to angle ZWA because they are both 40 degrees. But we can also say that angle XWZ is congruent to angle YWA because they are both 120 degrees. When we talk about which arcs are congruent, we can talk about both minor arcs and major arcs. So from the angles that we've already said were congruent, we have minor arc XY congruent to minor arc ZA. And we also have minor arc XZ congruent to minor arc YA. As far as major arcs, if we start with major arc YXA, we could say that it is congruent to major arc ZAX. And if we talk about major arc YAX, we can say that it is congruent to major arc ZXA. We now have a lot of information to draw several conclusions from the given information in number 9. If we know that in circle O, central angle AOB is congruent to central angle COD, then we know that arc AB is congruent to arc CD. Because the measures of central angles are the same as the measures of minor arcs. I'll go back and fill in the Y's in just a minute. Let's just see how many conclusions we can draw. We can also say that segment AO is congruent to segment BO, is congruent to segment CO, is congruent to segment DO, because all of those are radii of circle O. We can say that segment AB is congruent to segment CD, because if arcs are congruent, then the chords are congruent. If we know all of that, we can say that triangle AOB is congruent to triangle COD by side, side, side. And if I drew in the distance from the center of the circle to each of those chords, then I would know that those two segments that I just drew, segment OE and segment OF, are also congruent. Because if chords are congruent, then the distances to those chords from the center of the circle are also congruent. So I've gone in and filled in all of the Y's. If you want to pause for a minute so that you can go in and fill in all of your Y's, feel free to take just a minute to do that. In summarizing all of that, we can say that if we have congruent central angles, that implies that we have congruent arcs, which implies that we have congruent chords, which implies that we have congruent distances. And that holds true if we are talking about any of those parts in the same circle or in congruent circles. The next few questions want us to do some calculations. Question number 11 is asking what fractional part of a circle is an arc that measures 8 degrees? Well, remember that the entire circle is 360 degrees, so if we want the fractional part, then an arc that measures 8 degrees, that's 8 degrees out of the total 365 degrees, and in simplified form, the fractional part would be 1/45 of the circle. If we want to find the measure of an arc that is 3/5 of its circle, again, we want 3/5 of the entire circle, which is 360 degrees. And 3/5 of 360 degrees is 216 degrees. And question number 13 is asking that if a polygon is inscribed in a circle, all of its vertices will lie on a circle. Find the measure of the arc cut off by a side of an inscribed regular hexagon. Remember that regular means all of the sides are congruent and all of the angles are congruent. So if I do my best to try and draw what they're talking about here, so I have a hexagon, a regular hexagon, inscribed in a circle. So all of these sides would be congruent, and if it's inscribed in the circle, then all of the sides of the regular hexagon are chords of the circle. So if all of the chords are congruent, then all of the arcs are going to be congruent. The regular hexagon divides the circle into 6 congruent arcs. So again, the entire circle is 360 degrees, and the chords divide the circle into 6 congruent arcs, so each one of those arcs will measure 60 degrees.